Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about Part 1. Geotechnical Engineering, Soil, Question and Answer. 1. Define porosity. Soils usually consist of particles, water, and air. The porosity N of a given soil sample is the ratio of the volume of voids to the total volume of the given soil mass. Equals 2. Define density index. It is defined as the ratio of the difference between the void ratio of the soil in its loosest state and its natural void ratio to the difference between the void ratios in the loosest and densest state. It is also called relative density or degree of density. Equals slash where E equals natural void ratio of the deposit E. Max equals void ratio in the loosest state E. Min equals void ratio in the densest state. 3. What are the various types of transported soil? Aeolian deposit, alluvial deposit, glacial deposit, lacustrine deposit, marine deposit. 4. What is absolute specific gravity? All the internal voids of soil particles, permeable and impermeable, are excluded. For determining the true volume of voids, the specific gravity obtained is called absolute or true specific gravity. 5. What is dry mass density? The dry mass density is the mass of solids per unit of total volume, prior to drying, of the soil mass. Equals slash 6. What is specific gravity? The specific gravity is defined as the ratio of the weight of a given volume of soil solids at a given temperature to the weight of an equal volume of distilled water at that same temperature. Equals 7. Distinguish between porosity and void ratio. 8. How do you classify the soil? Residual soil, transported soil, porosity, void ratio. Soils usually consist of particles, water, and air. The porosity N of a given soil sample is the ratio of the volume of voids to the total volume of the given soil mass. It is defined as the ratio of volume of voids to the volume of soil solids in the given soil mass. equals slash equals slash 9. Sketch the phase diagram for a soil and indicate the volume and weights of the phase on it. Define soil mechanics. Soil mechanics is defined as the application of the laws and principles of mechanics and hydraulics to engineering problems dealing with soil as an engineering material. What is saturated density of soil? When soil mass is saturated, its bulk density is called saturated density. It is defined as the ratio of soil mass of saturated sample to its total volume. It is denoted by the symbol Sat equals plus slash 1 plus. Define the term residual soil. Residual soils are those which have remained over the parent rock from which they have been formed. They are relatively shallow in depth. They are characterized by a gradual transition from soil through partially weathered rocks, fractured and fissured rock to bedrock. How do you distinguish between clay and silt? Serial number. Clay, silt. 1. It is an aggregate of mineral particles of microscopic and submicroscopic range. Particles become dusty when dry and are easily brushed off hands. 2. The soil may be organic or inorganic. The soil may be inorganic. 3. Organic clays are more compressible because of the presence of finely divided organic matter. Potentially large expansion upon wetting. 4. Inorganic clays are generally more plastic than the organic clays. Difficult to compaction. What are the different types of soil structures? Following are the types of soil structures which have been recognized in various soil deposits. Coarse-grained skeleton structure. Cohesive matrix structure. Dispersed structure. Flocculent structure. Honeycomb structure. Single-grain structure. What are the minerals present in clay soil? Attapulgite, calcium smectite, chlorite, illite, kaolinite, smectite, sodium smectite, vermiculite. Define submerged unit weight. Where the in situ soil is saturated with water, the particles are subjected to an all-round thrust. The submerged unit weight is given by difference in the unit weight of a saturate soil and the unit weight of water. The submerged unit weight is the submerged weight of soil solids per unit of total volume, V, of the soil mass. It is also called buoyant unit weight. Equals slash equals. Define state of consistency. The term consistency refers to the relative ease with which a soil mass can be deformed and is used to describe the degree of firmness of fine-grained soils, for which consistency relates to a large extent to water content. The four states of consistency suggested by Atterberg are indicated in this figure. What is degree of saturation? In a given volume of voids of a sample, some space is occupied by water and the rest by air. In a fully saturated sample, the voids get completely filled with water. The degree of saturation S is defined as the ratio of the volume of water present in a given soil mass to the total volume of voids in it. Equals slash. The degree of saturation is usually expressed as a percentage and is also known as percent saturation. S equals 1, for fully saturated sample. S equals 0, for perfectly dry sample. Define water content. The water content W, also called the moisture content, is defined as the ratio of weight of water to the weight of solids in a given mass of soil. Equals slash times 100. Define plastic limit. It is defined as the minimum water content at which a soil will just begin to crumble when rolled into a thread approximately 3 mm in diameter. Plastic limit is the water content corresponding to an arbitrary limit between the plastic and the semi-solid states of consistency of a soil. It is denoted by the symbol. Define liquid limit. It is defined as the minimum water content at which the soil starts to flow. Liquid limit is the water content corresponding to the arbitrary limit between liquid and plastic state of consistency of a soil. It is denoted by the symbol. Define shrinkage limit. It is defined as the maximum water content at which a reduction in water content will not cause a decrease in the volume of a soil mass. It is lowest water content at which a soil can still be completely saturated. It is denoted by the symbol. Define toughness index, consistency index, liquidity index, flow index, and plasticity index. Toughness index is defined as the ratio of the plasticity index to the flow index. It is denoted by the symbol equals consistency index, or the relative consistency, is defined as the ratio of the difference between liquid limit and natural water content to the plasticity index. It is denoted by the symbol equals slash liquidity index, or the water plasticity ratio, is the ratio expressed as a percentage of the difference between the natural water content of a soil and its plastic limit to its plasticity index. It is denoted by the symbol equals slash flow index is the slope of flow curve obtained by plotting water content as ordinate or natural scale against number of blows as abscissa on logarithmic scale. Equals 1 2 slash log 10 2 1. Plasticity index is defined as the numerical difference between the liquid limit and the plastic limit of a soil. Equals. What is the use of consistency limits? The consistency limits and related indices are very useful for soil identification and classification. The limits are often in specification for soil compaction and in semi-empirical methods of design. The liquid limit and plastic limit depend on both the type and amount of clay. Define coefficient of uniformity. It gives the range of grain sizes in a given sample. C. U must be greater than 4 for gravels and 6 for sands. It is denoted by the symbol C. U equals 60/10. Define coefficient of curvature. Coefficient of curvature is a measure of the smoothness of the gradation curve. It is denoted by the symbol C. C. For well-graded soil, C must be between 1A and D3. Equals 32/10 times 60. What is quicksand condition? Sand is said to be quicksand condition when the flow is upward under a hydraulic gradient, which reduces the effective stress to zero. State the properties of flow nets. The flow lines and equipotential potential lines meet at right angles to one another. Moving parallel is not possible. the quantity of water flowing through each flow channel is the same. Similarly, the same potential drop occurs between two successive equipotential lines. Smaller the dimensions of the field, greater will be hydraulic gradient and velocity of flow through it. In a homogeneous soil, every transition in the shape of the curves is smooth, being either elliptical or parabolic in shape. State Darcy's law. The law of flow of water through soil was first studied by Darcy, 1856, who demonstrated experimentally that for laminar flow conditions in a saturate soil, the rate of flow or the discharge per unit time is proportional to the hydraulic gradient. Dot. Where Q equals discharge per unit time, A equals total cross-sectional area of soil mass, perpendicular to the direction of flow, I equals hydraulic gradient, K equals Darcy's coefficient of permeability, V equals velocity of flow or average discharge velocity. What are the various uses of flow nets? A flow net can be utilized for the following purposes: determination of seepage, determination of hydrostatic pressure, determination of seepage pressure, determination of exit gradient. Define the term geostatic stresses. The vertical stress in a soil to its self-weight is termed as geostatic stress. Define effective stress. Effective stress equals the total stress minus the pore water pressure, or the total force in the soil grains divided by the gross cross-sectional area over which the force acts. What is permeability? It is defined as the property of a porous material which permits the passage or seepage of water, or other fluids, through its interconnecting voids. A material having continuous voids is called permeable. What are the methods for measurement of permeability? The coefficient of permeability can be determined by the following methods. Laboratory methods. Constant head permeability test. Falling head permeability test. Field methods. Pumping out tests. Pumping in tests. Indirect methods. Computation from grain size or specific surface. Consolidation test data. Horizontal capillarity test. Define seepage velocity. The actual or true velocity of water flowing through the voids is termed as seepage velocity. Define discharge velocity. Quantity of water flowing in unit time through a gross cross-sectional area of soil at right angles to the direction of flow. It does not account for flow through soil voids. What is groundwater table? Groundwater is that water which fills the voids in the soil up to the groundwater table and translocate through them. It tries to fill completely all the voids. Define the term capillary tension. The tensile stress caused in water is called the capillary tension or the capillary potential. It is the pressure deficiency, pressure reduction, or negative pressure in the pore water, or the pressure below atmospheric, by which water is retained in a soil mass. What is laminar flow? Flow of fluids is described as laminar, if a fluid particle's flow follows a definite path and does not cross the path of other particles. Define the term coefficient of permeability. The coefficient of permeability, or simply permeability, is defined as the average velocity of flow that will occur through the total cross-sectional area of soil under unit hydraulic gradient. The dimensions of the coefficient of permeability K are the same as those of velocity. It is usually expressed as cm section. Water can flow through the pore spaces in the soil, and the soil is considered to be permeable. Thus, the property of porous medium such as soil, water, or other fluids can flow through it. It is named as permeability or coefficient of permeability. The percolating power of the soil mass is named as permeability. List the assumptions made in the Laplace's equation. The following assumptions are made in the derivation of the Laplace equation. The flow is laminar. Water and soil are incompressible. Soil is isotropic and homogeneous. The soil is fully saturated. The flow is steady, i.e., flow condition does not change with time. Darcy's law is valid. What is meant by contact pressure? Contact pressure is defined as the vertical pressure acting at the surface of contact between the base of a footing and the underlying soil mass. The actual contact pressure distribution, however, depends upon the flexural rigidity of the footing and the elastic properties of the subgrade. What are the approximate methods of determination of vertical stress under loaded areas? Equivalent point load method. 60-degree distribution. 2-to-1 load distribution method. State any two assumptions made in Westergaard's analysis. Westergaard's 1938 analysis is used to solve the problems on the pressure distribution in soil under point load, assuming the soil to be an elastic medium of semi-infinite extent but containing numerous, closely spaced, horizontal sheets of negligible thickness of an infinite rigid material which permits only downward deformation on the mass as a whole without allowing it to undergo any lateral strain. 45. Define the term pressure bulb or pressure bulb concept in soils. The zone in a loaded soil mass bounded by an isobar of given vertical pressure intensity is called a pressure bulb. Define influence diagram. The vertical stress distribution diagram, due to a concentrated load, at a depth if such a diagram is plotted for unit load, Q equals 1, it is called the influence diagram. What is an isobar or stress isobar or isobar diagram? An isobar is a curve or contour connecting all points below the ground surface of equal vertical pressure. An isobar is a spatial, curved surface of the shape of a bulb, because the vertical pressure on a given horizontal plane is the same in all directions at points located at equal radial distances around the axis of loading. Write the assumptions involved in Boussinese equation. The following assumptions are made in the solutions by the theory of elasticity. The soil mass is an elastic medium, for which the modulus of elasticity E is constant. The soil mass is homogeneous, i.e., all its constituent parts or elements are similar and it has identical properties at every point in it in identical directions. The soil mass is isotropic, i.e., it has identical elastic properties in all directions through any point of it. The soil mass is semi-infinite, i.e., it extends infinitely in all directions below a level surface. What is the use of Newmarks Influence chart? A more accurate method of determining the vertical stress at any point under a uniform loaded area of any shape is with the help of influence chart or influence diagram originally suggested by Newmarks, 1942. What are the factors affecting the contact pressure distribution? Elastic properties of the subgrade. Flexural rigidity of the footing. Type of soil. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.